and get started. So this week it's the intermediate data manipulation in Python. So really we're just going to be building off of the foundations that we had from the first data manipulation workshop. You're going to be learning a lot about some advanced subsetting with data frames. So I'm going to be introducing some new Pandas functions and advanced ones for slicing, filtering our data to look for specific observations, as well as get into some advanced iteration and Pythonic code, and as well as learning how to handle missing values in your data. So there's not much to this slide deck, so we're just gonna get right into it here. So I'll send the link to the data set here. This is a Titanic data set from Kaggle. Go ahead and do the same thing, download it to your files and make sure you have it for later. Just go here and click download. And then the other thing is the Collab Notebook, which we'll be working in. It's a view only, so make sure you go here. There's instructions here to save a copy in your drive. So you'll want to go here, click File, save a copy in Drive, and it will allow you to work alongside me. So go ahead and do that. And when you guys are ready, just give me a thumbs up in the chat or just let me know. Oh, and actually, you know what? I'm going to zoom in because I've been hearing that sometimes it's hard to see. So yeah. Okay. So assuming that you guys are ready now, you've got your, we're going to first import pandas like we always do, because we're going to use this function and this package throughout the whole project today. So let's go ahead and import pandas, right? So we do this as import pandas, and we have our alias name, which is PD, right? And so that's what we're going to be referring to. And so now let's upload our data set here. So let's go ahead, and if you run this code, you'll choose the file from your file system. So I've got it here. It's the Titanic CSV. And so if it doesn't load, remember, just make sure you just click refresh here and it'll show up here your Titanic CSV data set. And now we want to load this in as always, right? So let's set it to a object for our data. So I'm going to call it df for data frame, and we're going to call the read CSV function. So just to go over that, once again, you do pd.read CSV, and we want to specify the file path as a string. And to do that, to get our file path, you'll go up to your file, you'll right click on these three dots, and you'll copy the path, and then you'll go to this string in your quotations and just paste, just command v it or control v it, right? So now we've read it in, let's run that. So now we have our data in our environment. And now let's print the first 5 rows with the head function, right? df.head, and that will return to us our first few rows here. So we can see that our various columns that we're going to be dealing with, we can see that there's some NaN values. I'm going to be getting into that later on. And just overall, we see we got some categorical variables, some numerical variables. So some interesting things to look at. So, last week, during the last intro to data manipulation, I showed you one major way that we would subset our data, right? And, that was when we would, take all of the rows from our data, but specify the individual columns. So, what we did in the past was this method where we'd take our data frame object, treat it like an array, and pass in an array of the columns that we wanted. And this is great because this allows us to subset our data. But what if we don't want to work with all of the rows in our data set, right? Later, when we get into machine learning, we're going to want to split our data set into training and test sets, and we don't want to use all of the rows in our data set. So there are some handy methods that Pandas gives us, and that's the label-based location and index-based location slicing of our data set. So what that means is for these two methods, loc and iloc, I'm going to be first going over the label-based location, or loc. We will be again, same thing, treating our data frame as an array, but this time, instead of just specifying our columns, we're going to be also giving a row specification. So if you imagine this, right, if we have our data frame, we're going to be slicing it via the columns, all right, and our rows here. So we're going to be specifying this index as well as the columns. So that's why you see here when we'll be working with this is that we have a row specification and we have a column specification. Row specification refers to these index values and columns refer to our normal column names. So with the label-based location, we will call the .loc function on our data frame. And what this does is it allows us to customize what we want to slice. So let's say we want to get all of the rows from our data frame, right? With that, we just specify a column or a colon in the first argument. First argument refers to our rows. So that tells Pandas that we want all of our rows. And then this second argument is the columns that we want to specify. So here we select the column 1, 2, 3, and we keep all of the rows. And this is, okay, zoom in. Okay, yeah, for sure. And this is what this right here, this piece of code is identical to what we would do before, because you would select all the columns, but keep all, or select some of the columns, but keep all the rows, right? So whenever we specify this colon, that means we want to keep whatever, rows or columns. Let's say we want to get all of the rows, but specify the interval of columns between two things, right? So here we just select 3 arbitrary columns, but let's say you want columns 1 through 10. Well, if they're in a row, instead of just specifying column 1, column 2, column 3, and passing that huge array, we can just say, all right, we want from column 1 to column 10. And so, obviously we're not limited to just getting all the rows. With loc, we can specify, all right, let's say we want the first 2 rows from our data set, but 3 columns. So here we have, rows 0 to 1, and then whatever columns. Similarly, if we want all columns from 1 to 10 and 3 rows, we go from 0 to 2 and the columns 1 through 10. And then, it works in reverse, right? So let's say we want 3 arbitrary rows, right? We want the 25th sample, the 50th sample, and the 75th sample. We specify 25, 50, 75 as the first argument for our rows, and then the columns 1, 2, 3 for our columns. And then, similarly, if we have we pick 25 through 50 samples, right? So we take those 50 or 25 rows and then keep all of the columns. That gives us another subset of our data. So it's better to just start practicing with this instead of just talking about it, right? So let's go ahead and let's print our data frame. And let's first get all of the rows, but subset the survived, sex, and class columns. So, right, so we're going to call df.loc, and now we have to specify 2 arguments here. So the first one is going to be keeping all of the rows. So let's do a colon to show that, and then comma, subset the survived, sex, and class columns. So we're going to do that as an array, and we're going to do the survived, sex, and the class columns, right? And so when you see that here, we have got all the rows from our data set, and we have those 3 columns. So they would be the same thing as we did last time. Let's get all the rows, but subset all the columns ranging from survived to class, right? So let's get everything from the survived column all the way to the class. So we're going to be selecting all of these, right? So let's do df.loc. Let's go selecting all rows, and then go from survived to class. Unexpected indent. Loc, and then let's do the all the rows and from survived to class. So as you can see here, we've selected all the rows like last time, but we select everything from survived to class. So this only works if you want to select everything in between it. So that was how we would do it normally. But let's say we want to get the first 2 rows, but keep all of the columns, right? So now we're specifying our rows first. So let's do df.loc. And this time we want to get rows 0 to 2. So 0 to 2, right? And then let's get all of the columns. So let's do a colon for that. So what this does is that this returns us the first 3 samples and gives us all of the columns. So this is the beauty of loc is because we can specify our how many samples we want and slice it that way. Let's say we want to get indexes 60 through 100. We can do that as well. Let's go df.loc and let's do 60 to 100, right? And keep all of the columns. All right, this slices that part of the data set. So we get all of these rows and all of the columns, right? So you see how this is helpful when we want to split our data set later on and work with it individually. Now let's get the first 2 rows of our data, right? So we're going to get the first 2 rows and then get the fair, adult, male, and embark town columns. So we're going to be specifying 3 arbitrary columns. So let's do df.loc and let's go 0 to 2. And then the fair and adult male and embark town columns, right? So now we have specified 3 specific columns. So as you can see here, a lot of this is going to be pretty extensive because a lot of these methods, it just takes practice to work with. So this may seem repetitive, but trust me, like if you can practice this is the best way to be competent with it. So let's get the first 3 rows of our data set, but keep all of the columns from fair to embark town. So let's not just select 3, but keep everything from fair to embark town. So same thing, df.loc. 0 to 2 as our row index, and then everything from fair to embark town. Okay, now we have all of these. Let's go again. Index from 4 to 20, but select the embark, who, and deck columns. So df.loc, and then let's go 4 to 20, and embarked, who, and a deck. So you see here that we got from 4 to 20, and then we got our embarked, who, and deck. So already we can see here that our deck column has a ton of missing values. And this is great because at first when we printed our head column, we might have seen 2. It only shows the first 5 samples, right? We just saw like the first 3 being NaN. So we don't know how the rest of it is. So by doing this, we see, okay, there's a lot of missing values in our data set. So that's something to keep note of. All right, let's index 9 through 800, but select the survived, sex, age, who, and deck columns. So let's do df.loc, and let's get 9 through 800, right? And then let's select the sex, age, survived, sex, age, who, and the deck columns. All right, so we got that in. So we now selected those 792 samples from our data set and those specific columns. Again, let's get index 32 through 79, but select all columns from fair to alone. df.loc, 32 to 79, and everything from fair to alone. Fair to alone. Okay, right. We got all of these, and now let's specify specific samples. So thus far we've been getting everything from between two rows. Let's specify and get, let's say we want 32nd, 54th, and 90th sample, and then whatever columns that we've set, fair, adult, male, and alive. So df.loc. And since we want specific rows here, we're gonna have to pass this in as a list. And with that, we said 32, 54, and 90 as our indexes. And then now we want the fair, adult, male, and alive. So we're going to pass another list, and we're going to say fair, adult, male, and the alive, right? So this is a lot different from if we just said 32 to 90, because we're not getting everything from 32 to 90, right? That colon operator says we want everything from those two values. This, when you pass in a list, that means you want the specific values. So let's do one more. Let's do the 12th sample, the 34th sample, and the 60th sample, and all columns from fair to alive. So that's df.loc, and let's get the, what did I say, 12th, 34th, and 34th, and 60. And then let's get everything from fair to alive. So fair to alive, right? And now we have done this. So that was a lot. That was the location-based, label-based location. So the reason why it's called label-based is because we're always going to specify our rows as integers. That's not going to change. And the reason why is because the index values here are integers, right? But the reason why there's two different ways of doing location-based and index-based is because here in label-based, we're specifying the columns as our labels, right? Our labels are these individual columns that we specify in that second argument. So when we move on to iloc, right, data frame slicing with index-based location, this is exactly the same that we just did. Only difference is that we don't specify our columns as labels. We specify them as indexes. Now, I am not too much of a fan of this because you don't really know what you're slicing when you do index-based location, right? Unless you have memorized every single index in your column, you will really be just kind of experimenting with this, right? You know, I don't know off the top, like let's say you have a table with like, 500 different columns, you don't know exactly what kind of columns you can get from 20 to 30, right? But it would be better if you can label them with the specific columns. But I just want to show you this in case you prefer this way. So the only thing here is when you call iloc, same thing, our first argument in this, when we subset it, is the rows we want, and the second is the columns we want. So here, if we want to keep all rows but select the first three columns, remember in Python, it starts with 0 first, that's our first index. So from 0 to 3 returns the first three columns. Let's say we want to specify the third and fifth and seventh indexes, right? We want those three arbitrary columns. In index-based location, when you call iloc, you have to specify as integers, so 3, 5, and 7. It's similar here. If we want to get everything from samples 8th through 20, and this columns from the 7th index to the 10th index, you can do 7 to 10, 8 to 20, right? Same thing, except if you call iloc, you have to specify our columns as integers, and because you're indexing it. So this, right, let's practice with this. Again, it's, I'm going to be throwing a lot of similar functions to you throughout this whole notebook. You don't have to memorize. Obviously, the Pandas documentation is something I always refer to, but some of these, you can just kind of pick whichever you want and run with it. You really don't have to memorize all of these. So let's go. Let's keep all the rows, but select the first 6 columns. So we're going to go df.iloc, right? iloc, and we're going to keep all the rows. So we're going to do colon, and then select the first 6 columns. So let's go 0 to 6. Right. So now we have sliced it, and we've done the we've gotten our survive to parch. This would be similar, okay, if we did df.loc and did colon survived to parch, and if we specified them as labels, it would be the same thing. But with iloc, we just specify index values. Let's do keep all the rows, but keep all of the rows, but select the 2nd, 4th, and 7th index. So let's go df.iloc, and let's do keep all of the rows, and we want the 2nd, 4th, and 7th. So we're getting specific ones. So we want to pass in a list and specify 2, 4, and 7. So this is what it returns, and we've kept all of the rows. Now, let's select the 2nd, 4th, and 7th samples, but keep all of the columns. So this is the reverse, right? We're gonna specify 2, 4, 7 as our rows, comma, keep all of the columns. So this will return the opposite, right? We got the 3 rows, but all of the columns. Now let's select the first 6 rows in the first 6 columns. So let's do df.iloc, and let's go 0 to 6, and then 0 to 6, because we want 6 for each. And we see here that we have returned the whatever the first six columns and the first 6 samples were. Now let's do it again. Let's select the rows 20 through 90 and the index from 4 to 12 for our columns. So same thing, df.iloc, and we go 20 to 90, and then 4 to 12. So you can see how this is kind of like, well, I like to think of this as indexing into 2 arrays, right? Your index column is your 1 array, and your indexes are your 1 array for your rows, and then your columns are another array. So now let's select the rows from 30 to 35, and then the columns from the 2nd to 6th index. So df.iloc, 30 to 35, and 2 to 6. All right, so we got those specific samples. Now let's select specific ones. Let's select the 16th, 17th, and 83rd index on those corresponding samples, and then select the 3rd, 9th, 12th, and 14 column index. So let's do df.iloc, and let's go, we're going to pass in a list. So let's go 16, 70, and 83, and the 3rd, 9th, 12th, and 4th column index. So let's see. Yeah, so this is what we get here. And so you see that this is kind of why I prefer the label based, is because, I don't really know what the 3rd, 9th, 12th, and 14th index is off the top of my head. So that's why I tend to use the label based one. This would be the same thing as if you passed an age, who, embark, town, and alone in a list. That would be calling df.loc. And now let's select the 16th, 17th, and 83rd row index, and all columns from the 13th through 14th index. So df.iloc, and then let's go, we're going to pass in the list 16th, 70th, and 83rd row index, and then let's get all the columns from the 3rd to 14th index. So 3 to 14. So we return that. So as you can see, we're like, kind of slicing our data frame in different ways. So let's do select all rows from 16 to 83 and specify columns the 3rd, 9th, 12th, and 14th index. So let's do df.iloc, 16 through 83, right? And then the columns with the 3rd, 9th, and 12th, and 14th index columns. So we're passing in a list, 3rd, 9th, 12th, and 14th. And when we return that, we get our sliced data frame. And then last one, let's get everything from 16 to 83, and then everything from 3 to 14. So again, df.iloc, and we go 16 to 83, and indexes 3 to 14, right? And we get our new data frame here. So this is how, these are some advanced ways we can slice our data and really customize, what samples we want, what columns we want, and really get a chance to, take control over what we want instead of just selecting all rows, right? Because, once we use these methods and we slice our data frame in various ways, we may want to do, some further, and obviously, I've just done it like this, but it's always a best practice to save your sliced data frames to a new object. So, once we have these sliced data frames, we would want to explore them a little bit and kind of filter them and like query for specific values. And, this is where we would then use our various Pandas filtering and querying techniques. I'm going to be showing you 2 different methods here. Both work the same exact way, except one has more like SQL-like syntax, and one of them is just regular. So this is with Boolean queries. So what this is before what we would do is we would just select the specific column, but let's say we want to go a little bit farther and we want to look for a certain value in a column, right? So the way we can do this is we index into our data frame as normal, and we specify that column we want. So whatever column it is, we pass that in and index it itself. So this is kind of hard to read at first, but just think of it as this outside data frame is your first data frame that you're indexing into. And then this right here, what you're specifying is the column that you want to filter for. And whatever value that is, you're going to look for wherever that column is equal to that said value. And generally, if it's a categorical value, you're going to want to specify it as a string, whatever your value is. But if it's an integer, you don't have to do that. You can just pass it in as a normal int. So here, let's say we got one value, but let's say we want to check for multiple values. So the way we can do that is we can use this .isIn function. So what this does is it works the same way as this, but it would be a little bit tedious if we did multiple AND statements to look for different values. So what this does is you index into the data frame as it is, you specify the column that you're filtering for, and then when you call .isIn, you're checking to see if the value you're looking for is in this range of values. So you're kind of saying, okay, this is the column I'm filtering. Are the columns in these values? And if they are, then it returns that data frame with these specific values. And you wrap the isIn with parentheses, and you put the values you want as a array. And let's say you want to do for those who are not in a range of values. So let's say you want to look for something which is not in this value 1, 2, or 3. So you want everything in the data frame or from that column which is not in these values. So literally it's the same thing, except you add a tilde operator. It's kind of hard to see here, but this is the tilde operator on the side. Yeah, for sure. So I think it's better to see now. You can see that this is the tilde operator. And that's when you would say, okay, I want to search for the not these values. And then, you can even do conditional filtering, right? So let's say you want a certain value and a certain value. So what you do is you want to wrap your individual conditions in parentheses. So let's say I want to search for one value from a column and another one. So all you do is specify that first condition and operator, specify the second condition, and then you filter for both. Similarly, if you want to do OR, you do the same thing, except you want to do the it's like it's a pipe operator. I think it's just, that's what you call it. It's like the vertical bars that symbolizes OR. And then if you wanted to filter for integers, right, less than a certain integer, less than or equal to a certain integer, same thing, you look for the column less than a value or less than or equal to. Similarly, if you do greater than, equal to. So let's practice here. So let's print the data frame initially. And then let's filter the data frame for the male sex. So what we're going to be looking for is we're going to filter this data frame such that the sex column only contains males. So let's do that. So we're going to index into that data frame. And then within that, we want to filter for the sex column, which equals males. So let's do df sex. And then we're going to look for where that equals male. So male, right? And as you can see, it returns, and it filtered our original data frame. So you can see it went from 891 rows to 577 rows. So now we've looked for all the data with just the male, male as our label in the sex column. So we filtered that down. Now let's filter for samples where the embark town, right? The embark town value is Southampton in Queenstown. So again, if we're filtering for two values, we can use that .isIn function, right? So let's do df, and we want to do the embark town. So df embark town. And then we want to look for whether the values we're looking for are within the Southampton and Queenstown label. So let's call dot isin, and then we want to pass in a list for the values we're checking for, and that's going to be Southampton, Southampton and Queenstown, right? So if we run that, you can see here we have gotten our data frame back with just the embarked town being Southampton and Queenstown. You won't find this Cherbourg embarked town in this because we filtered for the embarked town values where it's within these constraints, these two values. But let's say we want to filter for everything which is not that. So basically we're filtering for everything which is just the city of the town of Cherbourg, right? So for that, we just wrap that same command, except we put a tilde operator to specify not. So we do tilde df.embarktown, right? Dot isin Southampton and Queenstown. Queenstown, right? So now we have just our embarked town being Cherbourg. So that is in value. And again, this you could have easily just made this look for df where df.embarkedtown is equal to Cherbourg. That would have also worked the same. But I wanted to show you how this is in function worked. So again, let's filter for the samples who are younger than the age of 18. So here we're going to be using that less than symbol. So let's do df, right, and look for df where the age is less than 18, right? So now when we do that, we've specified our age column and our given condition being less than 18, and you can see that our age column reflects that. Now let's look for the observations where people paid more than $50 for the fare. So let's do df where df dot the fare column, right, is greater than 50. And so when we do that, we get our fare all above $50, right? Now let's filter for two conditions here, and we want to filter for the data frame, such that we get the male, sex, and who are children. So to do that, we're gonna same thing, index into it, but now we're gonna specify two conditions here with and. So our first condition is gonna be in parentheses. No, it does not automatically filter out NaN. There's a different way to do that, and I'm going to be getting to that at the end, but that's a great question. You have to do that a little separately if you filter out NaNs. So for the male, sex, and who are children, so df sex where it is equal to the male label, and so that ampersand, and then those who are children. So this who column, who is a child. That's the label. It's hard to see, but within the who, the label for children is child. So it's child. So we've filtered for the male sex and those who are children. And again, you can see here that we have just our who column being all child and our sex column being all male. And we have specified all these conditions. Be careful with this. All your conditions, when you use these, have to be in parentheses because that shows that they're two separate. Also, it becomes easy to read when you do that. So that's the and. And now let's filter the data frame for the female sex or whose embarked town is Southampton. So, this is going to be two conditions, but with a or operator. So we're going to do df and then df for these, parentheses, don't forget that. And then the sex column where they are female, right? And then this is going to be or, so it's the pipe operator with or. And then the embarked town is Southampton. So this will meet one of the given conditions. So that's why you see male here, and that's because we said or, right? So it's going to be either one or the other. Whereas if you said and, you would only get females here. So that's one set. Now let's do a little bit more of a challenging one, right? we're going to filter the data frame for the kids who were under 18 or a child and did not survive or were not alive. So we're going to be looking at the age column here. We're going to be looking at who's a child and whether they were alive. So if you can see this, when we filter this, we're going to look for kids who are under 18 or they're a child. So that's going to be its own separate condition. And then that and who are not alive. So we're going to have this kind of nested conditions here. So here we're going to index into the data frame and we're going to have two conditions. So let's have one set of parentheses, and that's going to be whether they were under 18 or they were a child. But now within this, we have two separate conditions. So now we have to specify two more sets of parentheses. So one condition here and one condition here. And we know that it's going to be or. So it's the or operator, right? So that's our first condition. And we're going to look for the kids who are under 18. So we're going to filter for the age who is under 18. So that's the first condition, or whoever was a child. So that being child, right? And now, now you're going to come out of your parentheses here. So that's our first condition. And then our second condition is and who was not alive. So let's do the and operator for our other condition. And we're going to subset into the alive column where that is equal to no. So when we run this, you see that we get back everything that matches that condition. So, you know, this gets kind of hard to read sometimes, and you have to be careful with your parentheses. But just to reiterate what we just did, we indexed into our data frame. We met this first condition where they were under the age of 18 or they were a child. So whether those two conditions were met, and that was its own condition. So that's why we had two sets of parentheses within the big one, and that they were alive, and it was equal to no. So that's the Boolean queries. So that's one way of filtering our data frame. But you know, another way we can do it is this like SQL query kind of method. So with this, this works similarly to the last method, except we call this .query function. And when you call that .query function, your actual filtering that you're going to be specifying has to be a string. I don't know why it's a string, but whenever you use this method, you want to make sure that whatever you say is a string. So what that means is if you, let's say, you know, we check for a column being equal to another string. So that means you're going to be specifying another string within a string. I know that seems kind of complicated, but it makes sense because if our thing is a string at first, then that column equaling to another string is just going to also have to be a string, right? And then if we want to filter for multiple values, so let's say we want to check for a column being in a specific range, right? Instead of calling that isIn method, we can just say column in and then pass in a list of those specific string values. If we want to filter for values which are not in that sequence, we just simply say column not in that list of values, right? And then we can also do conditional filtering. So if we specify string here, we can do, you know, column equals a value. And then again, we want your parentheses to separate those two conditions, and then just say and column equals value. So here you don't need an ampersand. You can just say and lowercase. And then we can also do or, where if we say whether it meets one or the other, and you can just say your or that's just say or instead of the vertical bars. And then here, if you're gonna filter for your specific integer values, you can do your greater than and less than. And then since it's gonna be an integer, you don't have to, you know, make sure you just don't specify this as a string because it's an integer, right? So let's practice this. Let's put our data frame, and then let's filter for, we're gonna be running the same queries as before. So let's filter the data frame for the male sex. So let's do df.query, right? And we want to specify this as a string because that's what this method requires. And we're going to look for where the sex is equal to another string being male, right? So when we run this, we get all males. And so, you know, just to reiterate, since this query requires a string, we have to specify this whole query as a string. say the column is equal to the specific label, which is also a string, and then, specify that itself. So this works exactly as the other way. So now let's just practice some more. Let's do filter for the samples where Embarktown is Southampton and Queenston. So we're going to filter for every single using single. Yeah. So I haven't experimented with it, but I'm pretty sure when you use this this method, if you specify double quotes for your query, your individual string labels have to be single characters, or like the single quotes. That's a lot to keep track of. So I tend to use the other method, but that it does make a difference actually. So filter for the samples where Embarktown is in Southampton and Queenston. So we're going to do df.query and then our Embarktown column. And we're going to say whether it's in the Southampton and Queenston list. So we're going to just say in, and then pass in that list. But those individual labels are also strings. So we're going to do Southampton and Queenstown. So when you run that, it returns those Southampton and Queenston towns, right? So we have Embarktown in Southampton, Queenston, right? And then similarly, if we want to filter for those not in that, it's just simple, same thing. And we say Embarktown not in those two values, so Southampton and Queenston. And then, another reason why I like to, if I'm using labels in this, why I like to do single quotes versus double quotes, it just makes it, it's just a good practice to like separate those out so you know when to use which. It just makes it readable. So here we got all the data where it's just Embarktown. So you can see this is a lot easier when we just say not in versus in, right? Versus that tilde operator. Let's filter for the data frame for samples who are younger than the age of 18. So let's do df.query, and we're going to look for the age. So age being, and again, this is an integer, so we can just say 18 here. I know it looks a little bit confusing because the query itself is a string, but since it's an integer, we can just say 18, right? So this returns all the observations where the age is less than the age of 18, or kids who are less than the age of 18. And then let's do filter the data frame for a fare of more than $50. So df.query. And then let's do fare being greater than 50. And when we run that, we get everything more than $50. And so then let's keep going. Let's filter the data frame for the male sex and who are children. So we're going to use those, that conditional there. So we're going to need parentheses to separate our conditions. So let's do df.query. Our string, and then we're going to say where sex is equal to male, right? And so no ampersand, just and who are children. So who is equal to child, right? That's what we have here. So now you see here we have the, it has to meet both conditions. So that's why we get all male and all child here. So that's just specifying the and. Similarly, we can say what if it wants to meet one or the other. So let's do female sex or Embarktown is Southampton. So let's do df.query, and let's do the where the gender, the sex is female. So sex is equal to female. And then let's do or the Embarktown is equal to Southampton, right? So that's with the or, so it meets one condition or the other. So we see the males and females, and then the various towns. So that's using the and or. And then, this is the same one that we did prior, but this is the same complex one where we're going to have the kids who are under 18 or they were a child and were not alive. So this is the same example, but I'm just going to use the .query method. So let's just do df.query, and let's do quotations, right? So our first condition is going to be its own condition, and we're going to have and. So let's do and for the other condition. But within that, we're going to have two conditions. So we're going to have another set of parentheses for that, or the other set of parentheses. So you can see how this is falling together now. And then we have kids, the age being less than 18. So age less than 18 for our first condition, or who are children. So where who label is equal to child, and who are not alive. So where alive is equal to no. So with the .query method, we achieved the same result as we did above with the Boolean query. So, that's what you want to do after you slice your data frame. You learned how to slice it with loc and iloc to explore it a little bit more. And this is kind of like where you transform it. You can filter your data for specific conditions. You can, answer various different questions you have with these two methods, with the query and query method, and then just using the plain old Boolean queries. So again, these are two different methods. You can pick whichever one you want, but that's how you do it with Pandas. So once we kind of slice our data frame, we query it to certain values. Ultimately, we also want to kind of iterate over it and sometimes transform it a little bit. And for loops are great, but unfortunately in Python, there's a faster way to iterate over for loops. And I'm going to be showing two of those methods which work the same way. And one of them is called a list comprehension. And bear with me here because this can get kind of hard to read initially. But what it is essentially that it's kind of like a shortcut for a for loop. So how it works is you set your result array, what you want it to be, equal to the given list. So let's say I want my result array, that's going to be what's going to happen after the for loop has started. And it's going to be my output expression for the item in the lists. Okay. Now, I think it's better if I just kind of show you with an actual example. So let's see here, right? This is just your classic for loop. Okay. I have my list here. I specified my empty array, my result, and I'm going to iterate over that list and append my items and multiply them by 2. So, this is going to return a list with each element multiplied by 2. So this works, right? My list, result, iterate over it, you're done. But what a list comprehension does is it simplifies this code much, makes it a lot cleaner. So this is kind of what's known as your Pythonic code here. So the same thing, this is your my list that we're iterating over, but the way we specify the same thing is we say, okay, every item that's in this list, what we want our result array to be is it's going to have its output array be every item multiplied by 2 for each item in my list. Okay, so if we print this out, we get the same exact thing. And you see it's the same exact code, right? Our empty array result gets appended with item times 2 in our list. It's the same thing as if we said item times 2 for item in my list. So it's the output expression that we want for each counter in our list. So, you can do this with conditionals too. So you can do, let's say you want to return a list based on some condition. You can do your output expression for each item in that list if that item meets a certain condition. We can say, all right, let's do it based on an if-else condition. Let's do return an output if that condition is met, else a default output for each item in the list. And then same thing with if else. It's the output if the condition is met, else if, right? Else output 2 if condition 2 is met, else your default item for item in list. And again, this only gets better with practice. So let's start with some basics. So return a new list which adds 2 to each item using a list comprehension. So that's what it's called. So let's go with result. That's going to be our returned array. And we're going to what? We're going to add, we're going to double each of our elements. So our output expression is going to be each item plus 2 for item, all right, for each item in my list. And if we print that, we get, each of our elements being doubled. So this is, really simple. It makes the code a lot cleaner. Now let's do it based on a condition. Let's return a list with only even elements, right? So a hint I gave was we have to check if it's even. And the way to check if it's even is if the modulo operator by 2 is 0, right? So let's do result is equal to, right? We're going to print the item for each item in my list, right? So we're going to print it, but only if the item meets this condition where it's even. And if we run this, you can see that it returns the even digits. All right. And now let's do a little bit more complex. Let's return a list which prints every integer if it's even, or else it replaces every non-even integer with a star, with an asterisk. So with our result, we're going to have an if-else condition here, right? So we're going to print every integer if it's even. So, item, if item is equal to 0, so that's our output expression, item, if it meets that condition, else the star, right? So you can kind of see our if else here. If the item is even, print it, else this for item in my list. And we can see here it will print our result. It will print out each even number and then replace the non-even numbers with this. All right, and this is a little bit more of a complex one. This is your if, else if, and else, right? So we want to return a list which replaces every integer with a star, or else if it's an odd integer, it's going to be an ampersand operator, and the default is going to be nothing. So you can kind of see this if else if structure. If it's an even integer, make it a star, else if it's an odd, make it an ampersand, else make it nothing. Okay, so we go result, right? And we're going to print a star if it's even. So we're going to do star if item to if it's even, right? So star if it's even, else ampersand if it is odd. So with that, to show that it's odd, you want to do the modulo operator by 3 equal to 0. And then if those conditions aren't met, then we just want to say nothing, right? That's our default condition. And then that is for every item in my list, right? And now this seems a little bit unreadable. So the thing about this is you want to be smart when you use this. If you have a ton of nested conditions, just make your own function and it will be a lot readable, right? So just to kind of explain this, the if else if structure, if the item is even, print the star, else if, right? Else if it's odd, print an ampersand, or else just return nothing. And that is for every item in my list. So this is more useful when we use it in the context of our columns. So let's go with the alive column. So let's print our data frame here. And let's encode the alive column such that rows which have a label of no, encode them with a 0, or else make them 1. So to do this, let's set our alive column, since we're going to be transforming it, let's set it equal to the same thing, but we're going to be affixing it, right? We're going to be encoding it. So we said that for every item in alive, we're going to make it a label of 0 if it's equal to no, right? So our output is going to be no if label is equal to no, else it's going to be 1 for for label in df.alive, right? And then if we run this and then we print our data frame, you can see here that our alive column is no longer just no's and yeses. It's encoded with those 0s and 1s. So, as you can see here, the reason why I set original to the alive column is because we changed that alive column. So we said if it's no, make it 0, else make it 1, because there is either a yes or no in that column. And then for every label in that df alive, right? Let's do this one. Let's do for everyone which is Southampton, label it S, or if it's Cherbourg, encode it with a C, or else just label it Q for Queenstown. So that's going to be for the embark town column. So let's set that equal to the new embark town column. And let's go. So it's going to be S if it's Southampton, right? So S if label is equal to Southampton. Else C if it's the label is Cherbourg, right? So else C if label is equal to Cherbourg. And then if it meets none of those conditions, then let's just make it Q. Why is it Q? Because the remaining one is just Queenstown. So all those conditions for every label in df.embarktown. And let's do that, and let's check the data frame. And you can see here that our embarked town is no longer set all of these explicit words. It's just those encoded values. So that's how list comprehensions help us iterate over the given columns. And so Lambda functions do the exact same thing. Although with Lambda functions, you basically kind of, if you see this function here, right, multiply by 2. Let's say we wanted to iterate over that column and return the row times 2. So what that does is it just, we get the column name and we do dot apply. So that's the apply function. So we're going to apply that function to that column, and then we specify that column, or that specify that function. So we could very well just say, this is how you specify a function in Python. Just say, call it multiply by 2, give it a row parameter, and return every row times 2, and then pass that into this apply function. But it's, when you do it with a Lambda function, what you do is you're kind of doing a anonymous function. So what you do is you say, same thing, that column name dot apply. So we're going to apply a function over it. But here, this is kind of implicitly specifying a function. So when you do lambda row, this is kind of just saying, if you just said def multiply by 2 row. So lambda means it's a lambda function, and whatever you give after it before that colon is your parameters. So our parameter is going to be row. So the function lambda with a parameter row, and then what we want to do to that function, in that function, is multiply each row times 2, and we apply it over this column, right? And then same thing, we can also do conditionals, where if it meets a given condition, it's the value if the condition is met, else it's a default value. For if else, it's a certain value if the condition is met, else a default value if the condition is met, else another value. So let's just practice this. I see I'm getting over here to 8:30, so we might go over tonight. So if you need to go, you can. This will be recorded and uploaded, so if you want to go back and watch, otherwise you can stay. I'm going to keep going just because I'm going to be recording this and uploading this. So yeah, so let's encode the sex column where if the gender is male, encode it with a 0 or else 1 using a lambda function, and assign this to the sex column to make the changes. So what we're going to do is we're going to change that sex column, right? And then we are going to do df sex, and we're going to apply a function over it, which is going to be a lambda function. So lambda, right? So this means that we have specified an anonymous function with a parameter of row, and we're going to encode it where if the gender is male, it's going to be 0, and if it's not, it's going to be 1. So 0 if row is equal to male, else 1, right? Because that's the default value. And so when we do this now, you can see here that our sex column went from male, female, male, female to just zeros and ones. And you might be wondering why we encode it like this. And that's because for, when we get into machine learning, into later workshops, all these algorithms cannot take in these categorical strings. It needs integers. It needs these encoded integers for it to make any sort of predictions. So this is why we encode these categorical columns. So again, we have, let's try it again. So let's encode the who column, where if it's a man, encode it with 0. Else if it's a woman, encode it with a 1. Else the default value is a 2, and assign this to the original column to make the changes. So let's go df who, and let's apply it to the who column. So apply, and it's going to be lambda function, which means it's anonymous. So lambda row, which is a parameter, which is what we're going to check for, make the various checks with. So if it's a man, encode it with a 0. If row is equal to man, right? Else 1 if row is equal to man or woman. And then if it doesn't meet those conditions, else 2, for that's probably going to be child, right? So if, else. Let's run that. And then let's check our changes, and we can see here that the who has changed from man, woman to zeros and ones. So this apply function works just like the list comprehension. It's just, it's just a different way of doing it. I tend to use both interchangeably, but definitely use the lambda function or the list comprehension over your normal for loop, right? Because if you have rows with hundreds of thousands of rows, you're not going to want to iterate through it with a for loop, and these functions iterate through it fast. And so I'm not going to do this one, but on your own time, I just challenge you to encode this adult male function by yourself, or this adult male column by yourself. So with that, we've learned to slice, we've learned to filter our data, we've learned to apply various functions over it. But now let's kind of get into data imputation. And what data imputation means is basically just when you have missing values, right? We've seen these NaN values in our data. These are things we have to address because, any models can't take missing data. And so I'm going to be showing you a very, simple way of doing it. But, whenever you replace missing values, you generally want to do a bit more analysis when it comes to how you want to do that. I'm going to be showing you how to fill those missing values with the mean for numeric values, and then the mode for your categorical values. And that solves the problem. But in real life, when you're actually working on a data science project, you want to communicate with people to see, why your data was missing, and kind of do some more analysis with that. So here, to check for if your data frame has any missing values, you call this df.isNull.any. So that's going to return, if we print the data frame, right, and we go isNull.any, right, if we run this, this returns Boolean values. And for every column which says true, this indicates that that column has missing values. So we can see here that, okay, our age, our embarked column, our index column all has missing values, and the rest, which are false, we don't have to worry about. But let's say we want to get, the specific columns. Well, to do that is you just pass this command in to this df.columns, and df.columns in itself is an array. So we can pass in this, and we can see what the output is. So df.columns, right? And let's treat that as an array and pass in df.isNull.any. And if we run this, we get the specific columns which met that condition. So since this was a condition, we can see that it returned the specific columns where we have null values. So that's the age, embarked, and dec, right? So now let's replace the missing values. So to do that in Pandas, we can do this with the .fillNA function, and this takes in 2 arguments: the value which you want to do it with. So sometimes people fill that value in with a 0, or you can fill it in with anything, right? and then you want to specify this in place equals true. What this does is you want to make sure that those values are filled. If you don't specify that, then it's just going to, it's not going to take hold. So let's replace the column missing values. So let's replace the age column with the mean age and make sure that the values get filled in place. So to do this, let's do df dot what is it, age, and let's do dot fillna, and our value is going to be the mean of the age column. So we're gonna replace those NaNs with the means of that age column. So let's set our value equal to df.age dot mean, right? And then let's make sure in place is equal to true. So now if we check this, if we run this same command, and let's check. So now you can see here when we did this, our age column is gone, and that's because we filled those NaNs, right? We filled those NaNs with the mean. And so you can see here now our array has shortened. So now we have to take care of the embarked and the deck columns, right? So let's replace, so let's print the data frame. And now we want to replace the embarked and deck. So embarked and deck are categorical columns. So, we can't just do the mean. So what I like to do is I like to replace the categorical columns with the mode, or the one which came up the most. So to check what the mode is, let's use that value underscore counts function. So let's do, df embarked dot value underscore counts, right? And when we run this, you see here that this itself shows that 644 is the one that showed up the most. So we're going to be replacing those NaN values with S in this case. And to get that value S, we're just going to index into it with the 0, because this itself is an array. So we can just do df embarked value underscore counts square bracket 0. And you can see here we get 644. So that's the mode. So let's replace those missing values in embarked with this value, 644. So let's do df embarked count dot value, or no, dot fillna, fill na with the value underscore counts, but the mode, so that first value, and where the in place is equal to true, so our changes take hold. So you can see here we filled the missing values with the that 644, that mode of the embarked column. And so now if we run, right, if we do df.columns and then do df.isNull.any, we can see here that now we just have deck. So we've now filled another column with the missing values. We filled our missing values. So now let's take care of this deck column. So since deck is also a categorical value, we're going to do the same thing. We're going to replace the deck values, the fill na, those missing values with the mode of the deck column. So let's do df.deck fill na, and then our value is going to be the mode of the deck column. So df deck dot value underscore counts, and then index into it 0 to get that first mode, that first value, and then in place is equal to true. And when you run that, let's now check once again if our changes have taken place. And we can see here that this is empty. And now if we do df.isNull.any, we can see that everything is false, our data is filled, and we have no missing values. So our data is ready to go forward for any modeling, right? We've cleaned our data set. So that's it for today. I know we went a bit over time, but this was a lot of content, so I expected that. But a lot of this was pretty advanced. You might have noticed this was definitely a big jump from our introduction to data manipulation. So the list comprehensions, the Lambda functions, if you thought that was, a bit hard at first, on that Canvas course, I'm assuming that the BDA Data Mastery course is able for you guys to access now. You can go on there, and there is a Python resources section, and there is a course where it takes you through the basics of Python programming. So it'll let you dive deeper into things like iterators, those Lambda functions, writing functions, and other data structures in Python, because we use a lot of those today. And yeah, that's it for today. If you guys have any questions, you can stick around and ask me, or message me on Slack. And yeah, just go out and practice this stuff. I know I probably worked you guys tonight, so yeah, go rest.